What if we could build a product that we could build into every consumer car, where we could take the latest AI, connect it to cameras, connect it to an advanced computer, whose sole purpose is to figure out what does the driver want?
Welcome to Talking Autonomy. I'm happy to welcome John Hayes, our CEO and founder here at Ghost, to join us today. Welcome, John.
Hi, great to be here, Matt.
Awesome. So generally in these sessions, we kind of go deeper on one aspect of the technology, but I thought with you here today, it'd be fun to just kind of get a little bit more into the origin story and thinking around Ghost. And in particular, one of the things that is unique about the autonomy we build is it's not meant to replace the driver like a robotaxi where, the driver is not even going to be around, maybe there's no steering wheel. But we're obviously building for consumer cars, which means there's always a driver there. We're selling and we're working with our partners who are car makers, and they want to sell to people who buy and drive cars. And so it's a very different thought process for how you build autonomy that kind of works with the human and the human enjoys using versus replacing them. And so why don't you just walk through a little bit of how you thought about that problem and what makes it different?
The first thing that makes it different is that when you have a driver, you don't have to self-driving everywhere all the time. And that's been a massive challenge for the other autonomy companies out there. But then when we look, and it allows you to shape the product in a way where it means that you can look at what is the driver intending to do? Like, what are they intending to do through their controls? What are they intending to do through where their attention is paid? And focus on, instead of taking the narrow focus on, hey, how do I get from A to B? It becomes, how do I make the car smarter and more responsive to what the driver actually wants to accomplish in that moment?
Yeah, I mean, in a Ghost, we don't necessarily do driver monitoring. We call that driver intent for that reason, right? We're trying to understand what it is the driver is intending.
Yeah, a lot of ADAS type products use driver intent or driver monitoring to figure out whether you should disable the product.
Yeah.
And something that we believe is, well, if someone's not looking out the window or they're not looking at the road, that's probably when you need automation the most, right. To make the car make good decisions. And on the freeway, when you're in an environment that we can support at a level 4, that's part of the activation, to know that someone isn't intending to drive and that the system should fully take over at that point.
Right. Yeah, and so, the product that we've started with at Ghost is basically a attention-free autonomous highway pilot, right? Fully able to drive the car without the user on the freeway. But it has a pretty novel way that you kind of engage or turn on autonomy that's a bit different than your classic push the button on my cruise control, right? Like, walk us through that.
The first thing is Ghost is always enabled. Like, it's always plotting where it should go. It's always looking at the scene. It's always looking at the surrounding traffic. And that's the foundation of a lot of the safety features built into Ghost. So what that means is that we track where is the driver actually going and does it follow the same plan. And when someone is taking the same action as Ghost, they're following the arc of the road, they're following at a reasonable distance, we actually start providing a little bit of feedback through the steering wheel so that people can feel it's like the
feel
car,
Ghost there.
Yeah, you can feel that that Ghost is really trying to create some gravity towards the center of the lane. And at that point, once you have that confidence, you can let go whenever you want. And the car will keep following the road, and it'll set a reasonable distance and a reasonable speed that is totally dependent on traffic conditions.
And so, yeah, I mean, in my experience driving inside a Ghost vehicle is that it totally changes the way you think about that equation, right? When you enable cruise control normally, it's very fidgety. You got to get in the right lane, got to get in the right spot, got to be at the right speed, got to hit the button, got to sense, all right, is it really working or not? And then you can kind of relax a little bit. Of course, you still have to monitor it. In our case, it's a very different experience where you just have to kind of like guide your car into the lane or so and let go, and you're off to the races, right? And it just kind of senses that and takes over.
Yeah, it senses that it's going to fill in all the gaps you leave. And so if you decide that you're not steering, Ghost figures out you probably want to follow the road. You probably don't just want to go off in a random direction. And these things seem obvious, yet most cars don't implement them that way. They assume that unless you push the button, then by default the car should just do wherever physics leads it, as opposed to by default doing the most intelligent thing that it can think of.
Okay, and so one of the opportunities that we're exploring is not only how do we deliver these capabilities on the freeway, but now that we know how to drive, how do we pull some of these back into other ODDs and to normal everyday driving to kind of enhance that driving experience? Talk to me a little about that. How might that work?
So we think about suburban driving a little bit different because it's a more complex scenario. Yet there's lots of things that you can identify in the environment, be it lane markers, they're the same as they are on the freeway, other vehicles, other road users, be they bicyclists or pedestrians. And all of that is identified in universal collision avoidance. And so what that means is that on an ordinary surface street, even if we don't feel like we have the total redundancy, that the car should still have a default behavior where it's following the road, it's not entering into a collision, and is responsive to the environment and actually also responsive to your intention, the amount of attention that you're paying.
Yeah, I mean, even just those two basic things. I mean, I can imagine if my car by default just kept itself in the lane I was in, and if I didn't hit the thing in front of me, that removes an enormous number of the safety problems that are on the road today.
Most of the safety problems that you see in urban and suburban environments are people who've lapsed their attention for a while. And so if the car can be filling in some good default behavior, like slowing down around pedestrians or bicyclists or not colliding with other vehicles or not driving off the road, those seem like very, very sensible things to do.
Yeah. I mean, compare that experience today to what's out there. I mean, typical cars today have existing ADAS features, safety features. Those safety features are pretty rudimentary. I mean, why are they so limited in their capabilities?
If you take a safety feature like emergency braking, often that safety feature has been designed to brake at the last moment. And they have an assumption that's built in. One is that you're looking out the window, you're driving intentionally, and only at the last moment would they put on the brakes. And something they're trying to do is they're trying to avoid braking in a situation that doesn't warrant it. Now, the trouble is that these features, usually they're built almost entirely in the radar system, don't understand the entire scene. Like they don't understand what you're trying to do. Now, the way we look at it is attention monitoring can be used to actually divide up two scenarios from each other. One of them is that you're looking out the window, you're doing something intentionally, you have a plan where at the last minute you're going to move or you're going to go around an obstacle or you know something about the road and the system should not activate. The other case where you're not driving intentionally, you're not looking out the window, your steering wheel, your control of the car is very loose, at that point, those safety features should activate sooner. They should activate sooner and more subtly.
Yeah, why not catch it early, right? Why wait till the last moment where there's truly an emergency that you have to respond to?
If you can catch these safety problems earlier, then you don't have to respond as dramatically. And then you're not as worried about, what if I get rear-ended because I've slammed on the brakes? Because you're slowing down at a reasonable pace that's going to be much more predictable to the traffic around you.
Yeah. All right. So, a lot of the folks out there started by building these basic driver's assistance technologies and of making their systems more capable with the hopes to eventually get to, full driving or full autonomy. We kind of went the opposite way, right? We started by building a completely attention-free autonomy system for the freeway. And now we're taking that ability to drive and bringing it back into always-on ODDs and finding ways to add safety and comfort on every street. So why was that the right direction to go? Why did we go that direction?
First, we actually went that original direction. We thought, hey, to make a safe system, you have to make safety features, which seems like an obvious relationship. And we discovered that those safety features can't give you the whole scene, or they can't give you the whole solution.
Yeah, I mean, the problem with ADAS is it doesn't know how to drive.
It doesn't know how to drive. And there's a lot of subtlety in understanding what normal driving is. And so we pivoted to look at, hey, let's focus on making normal driving really good. And something we discovered along the way was, in the scope of normal driving, there's a lot of pre-safety features that you can activate. Like one of the things we built was ambient speed detection. The reason we built that was because we were seeing that at a simple set speed, you would end up driving too fast in some scenarios. Versus if you look at all the traffic, you can slow down a bit. And small changes in your velocity can make a very big difference on the eventual impact of a safety feature. If you can reduce your speed by 5 miles an hour, that reduces your stopping distance by a lot more because that's aggregated over the entire length. And so we found that going from normal driving, the next step was making accident avoidance, like avoid triggering safety features in the first place. And then the last thing you do is safety features. And that is intrinsic in our system, but our goal is to never activate a safety feature, because usually that's going to create a lot of disturbance in the environment around you.
Yeah, absolutely. I mean, if you can sense a situation's maybe starting to become unsafe and act early, then that's way better than than waiting to the last minute. It also gets to, one of the challenges we've heard from a lot of the automakers is that they're really worried about false positives. And so today, they're very sensitive that users will be so bothered by the false positives hitting the brake when there really wasn't a problem, that they'll turn those off. And indeed, a shocking number of people actually just turn off or defeat their own ADAS capabilities that are there to make the life safe, right? And so, how do you think about making sure we tune the system appropriately so it's actually, a pleasurable experience to drive in versus annoying?
So false positives are a reality in any sensing system, where you're trying to make a determination as to, am I going to interact with this other vehicle? Am I going to interact with this person? And we found actually helps manage that effect is, one, you can look at the indirect behavior of other vehicles, but the other is you can directly model that uncertainty. So for example, if you look at a car that's far down the road, like 50 to 100 meters down, it's actually very difficult to tell whether it's actually in your lane or moving into your lane, because on a camera that's been reduced to now maybe 10 pixels wide, moving by fractions of a pixel, there's no radar system that would give you that resolution. But if you're coming up on something, what you can do is you can slightly adjust your speed. And that slight speed adjustment allows you to get closer in a relatively safe way until the resolution increases. And as long as you can keep that within the range of comfort, where someone almost never notices that the speed adjustment has occurred, you can make a system that has very few false positives, because by the time you're close, you have a lot of resolution to work with, and you'll have very, very accurate positives and negatives. And so some of that becomes building in the uncertainty, reacting in a soft way, and not waiting until the last moment. Like, you don't have to speed up to something that might be in your lane. You can approach it just a little slower.
Yeah, makes a ton of sense. And if I continue to play this forward, right, we're bringing more and more of these capabilities into everyday driving. The first step is to make sure that safety exists. But the part of building safety is building comfort. And so the other dimension is just to make driving much more comfortable, much more less taxing and whatnot over time. And how do you think about that? How does the everyday driving experience evolve to just be better driving?
There's definitely a relationship between safety and comfort, because everyone has a bit of a spidey sense built into them. Like, is a car just a little too close to me on one side? Am I cruising next to someone in their blind spot? Am I going too fast around surrounding traffic? Is there something weird going on? It could be a construction zone, it could be something pulled over. And so what people tend to feel in terms of, is this comfortable driving, is also predictive as to whether you're going to get a safety interaction. So what we think is that there's a lot of fusion between focusing on the comfort of the people in the car, whether they're looking out the window or they're not, and the ultimate safety that will be produced by that driving.
All right, cool stuff. Well, look, just to close us out here, you have a real gift for thinking way beyond the average human. And so play this forward for us. Think about 5-10 years out. How does this kind of collaboration between man and machine and AI to drive a car just expand over time? And what's it like to drive in a decade?
I think that we started the company at a time when cars are going to get a lot smarter in terms of their sensing, in terms of their compute, that hardware package. And I think that the way that the software changes is, first, the car is not now a literal control system where you turn a steering wheel, the car is guaranteed to turn a certain amount. In fact, the way you start interacting with the car is a combination of just directing approximately where you want it to go. It looks at where you're glancing, it looks at where you're trying to navigate to, and it's just filling in, and you're sort of collaborating with the car. And that scalability is very attractive to me, because there's always going to be complex driving scenarios where it's like you're parking. Near where we are, there's Shoreline Amphitheater. And if you go to a concert there'll be a person lazily waving a wand telling you where to park. Well, AI systems aren't going to get that. So there's a mode of direct control that's always present. But as you get into more structured environments, we want to just constantly lighten the amount of control that you have to do. How precise do you have to drive the car? The car should feel like it's it's doing exactly what you want all the time. And the only time you intervene is it's just an expression of, I want the car to do something different. I want to go somewhere different.
You're giving it loose commands, and it's
Exactly.
following. Yeah.
And the car is fixing it up, and it's staying in a lane, it's going around bicyclists, it's like really allocating space and always just trying to keep you in the safest position. And what's important to me is you never notice it's happening. It just feels like something that's built in. There's no more lights, there's no more warnings. It's just the car does the right thing all the time.
Sounds pretty amazing. I mean, another thing that I think you've talked about just around the experiences, we know that we've been successful when people will not ever want to drive in a car that doesn't have Ghost, right? It just feels so natural that the drive just happens, and they can't imagine life without it. So love the vision, and we have a lot to build over the next decade.
We definitely do.
All right, thanks, John.
Thanks.